So hi everyone. Thank you so much for coming out, and I'm so happy to hear that you guys have clear skies finally. So that's a good sign. We're off to a great start. So thank you, Isaac, for that introduction. Just once again, my name is Kat Troche. I am an amateur astronomer based out of New York City, and I like to kind of consider myself a professional amateur astronomer, an informal educator. I professionally, by day, work for the Astronomical Society of the Pacific as an administrator for NASA's Night Sky Network. And Night Sky Network is a collection of 400 astronomy clubs across the country. And we organize webinars like this one for experts to come and speak with audiences and to speak with astronomy clubs about anything that's going on in the science community. I'm also a NASA Solar System ambassador, and that's a volunteer organization within NASA that shares the science through things like this. And I am the vice president of operations for my local astronomy club in New York City, the Amateur Astronomers Association. That's just a little bit about me. So I really like to start off this talk with kind of a fun joke, and it's a little bit of a memory game for you, so that if anyone asks, what's a solar eclipse? If they're just asking you, you have this great way of telling them. So you have a lunar eclipse, and that's when you have moon, earth, sun. You have a solar eclipse when it's earth, moon, sun, and then you have an apocalypse. This is the last. The last one is the one that you don't want. That's the one that is not great for us. So what makes this eclipse so special is that in 2017, if you all remember, we had this really nice band of darkness here, this path of totality that cut all the way from the west coast to the east coast. And you can see the size difference between 2017 and 2024. This upcoming eclipse has a wider path of totality, which means more folks are able to experience this eclipse. If you live in the path of totality, that's fantastic. But even if you are outside of the path of totality, you will experience a partial eclipse. And that is true for the entire lower 48. So you have a 57% wider path, and we'll talk a little bit about why that is in a moment. You'll have longer darkness times. So in 2017, on average, the totality band was about 2 minutes long. For us in totality now, anybody that's going to visit or they just happen to live in totality, you're looking at upwards of 4 minutes, sometimes 4.5 minutes, depending on where you are. And it's a great excuse to go to Ohio if you decide to go visit the sunny beaches of Cleveland. Now, when you are the moon, you can do cool things like block out the sun. And the reason we have things like solar eclipses is because of this fun word called syzygy. And syzygy is when you have three objects in space that happen to appear as if they're in a single line. So for the solar eclipse, you'll have the sun, you'll have the moon, and then you'll have the earth. That is what's called syzygy. Another great thing about syzygy is that it is 29 Scrabble points if you play Scrabble at home. And if you say it 5 times fast, you end up doing like a tongue twister thing, which is kind of fun. So this is syzygy in action. So you'll see here, we have our sun, we have our moon, and we have our earth. And even though this is not to scale, obviously, this is more or less what it looks like in space. So you'll have this very narrow band of shadow that cuts across the earth as the eclipse is passing by. And then you'll have these slightly lighter bands, and that's the penumbra shadow. So right here, this full shadow is what we call the umbra. Now, of course, again, like I said, this isn't to scale, but this is. And this was taken with NASA Eyes, which is a piece of free software that you can use online. And you'll see here, based on distance and scale, you'll have our sun all the way in the center of our solar system. You'll have a little bit of lunar orbit here, and then you're able to see these two cones. And so you'll have the one that's kind of a lighter purple is the penumbra, and then you'll have that really, really kind of heavy purple that's very centralized, very focused in the center. That's the umbra. That is what's going to give us our totality in that path. Now, of course, because we're on the East Coast, we're not going to get full totality. If you wanted full totality, you'd have to go to Western New York, or you'd have to go upstate to Vermont, or upstate, go up towards Vermont. But that's where you'll experience totality. But if you stay in New Jersey, if you're in the the tri-state area, you'll get a partial, and that's that penumbra that you're seeing, these outside regions. So to see that in action, this is how the moon's shadow is going to cut across Mexico, the United States, and into Canada. So you see here, these percentages tells folks exactly how much they're going to get outside of the path of totality. Of course, the path of totality is 100, but anything outside of those margins will be, 95%, 90%, and so on. And it's just a really great way of seeing this visually as the Earth spins and as the moon is moving in its own orbit. We're able to see how this flows. Now, why does this happen? We now know the science, of course, as to why we have this, what we call a cosmic coincidence. So the sun's diameter is about 1 million miles, and its distance from Earth is about 100 million miles. Moon's diameter is about 2,300 miles, and its distance from Earth is 230,000 miles. So from our perspective, the moon and the sun have a size distance ratio of 1 to 100. They look like they're the same in the sky, even though their sizes are off, like their sizes are way different from each other in real time. And they and their orbits are of course different. But because of the size of the moon in relation to us and the size of the sun in relation to where it sits, it looks like they're the same size in the sky. So what makes eclipses especially special for us on Earth is that no other planet in the solar system can do this. You have transits where you'll have very small moons moving across the sun for that planet. Mars is a really good example of this. Both of its moons are incredibly small and also kind of oddly shaped. So you don't get that full blockage. You'll never get like a total solar eclipse on Mars. And it's just a cosmic coincidence of how large our moon is in relation to other moons in the solar system, how far away our sun is, and just that perfect alignment of when the moon moves between us and the sun at that 5-degree tilt. So there are types of solar eclipses, and these are the three that you want to look out for. So you have good, which is a partial. You have an annular, which was that ring of fire eclipse that we experienced in October of last year. And then you have what I consider the best, which is the total solar eclipse. And total solar eclipses, of course, give you this nice little diamond ring effect. If you are experiencing an annular eclipse like last year, that would be that ring of fire effect. But we in the tri-state, we're going to get a partial eclipse. And it's going to look something like this on April 8th at 3:25 p.m. Now I'm in New York, so I have it set to New York time, but our times are give or take a few seconds the same. So the partial eclipse is going to start at 2:10 p.m. We're going to hit maximum eclipse by 3:25 p.m. and the partial will end at 4:36 p.m. So as much as people want to look at the eclipse and they, as soon as they hit maximum, they say, all right, it's done, it's over. There's still so much eclipse left. And so I encourage you all to, if you have your solar glasses, to stick around, keep watching it as it moves across the sky. It's just such a nice and invigorating experience to see this cosmic dance with the bodies in our solar system. And now this is just from a New York perspective. This is what it's going to look like as it's moving across, let's say, Manhattan. Now, you'll see the exact same thing. It'll be 90% for East Brunswick, so that's not going to change. But this is what it'll look like as the moon is moving between us and the sun. You'll get that nice little bite right there. It almost looks like a cookie shape. And then as it keeps moving, you'll finally get that sun back into full view. And this is going to last all afternoon. So if you're able to take the day off, I absolutely encourage you to do so, and we'll get to that in a little bit. But just one more time, just so that you can see exactly how much of the sun is actually going to be obscured by the moon. It's just such a little tiny sliver that's left, but it does make all the difference. 90% is not totality. So if you are outside, of course, you'll start to feel that temperature drop, and you'll start to hear the birds singing as if they're going back to their nests. but it's not going to get completely dark like it would in totality because we're only getting 90%. And because of that, you have to leave your glasses on for the entire duration of the eclipse as you're watching it. Now, if you do go to totality and you decide you're not going to stay home, this is what you can expect at totality if the sky is clear. You'll be able to see all of the solar corona. You'll be able to see some flares here at the end. And it's an amazing, just kind of fun experience. It's just this really enjoying, just like, it's mind-blowing, truly. You'll get these flares that are here. You'll get the solar corona, and you'll see other bright objects like planets or stars. For April 8th, specifically, if you're going to totality, you can expect to see Jupiter and Venus, Mars and Saturn, and possibly a comet, even though it's going to be a little faint. So it all depends on how dark it is and if you have clear enough skies. Now, let's get to the eye safety portion, because this is the most important part of the talk. If you are going to stick around, no matter what you do, if you're going to totality, if you're going to stay home, you need to practice safe just eye safety in general when you're observing this eclipse. So on a regular day, you can definitely use your solar viewers. You can use your eclipse viewers. That's completely fine. For the eclipse, it's especially important to view it because that light is just going to be so heavily concentrated. When you're in these partial phases here, like we will be in the tri-state, you're going to want to keep these on the entire time. Sunglasses are not safe. You don't want to use regular sunglasses. You have to use ISO rated glasses. You have to use eclipse glasses. In totality, only in totality, is it safe to take off the glasses during those few minutes of totality. But then as soon as totality ends and you go back into that partial phase, you have to put the glasses back on. Now, can you take pictures of the eclipse with your cell phone, with your camera? Yes. Can you do it without a filter? No. You have to use a filter even for your camera or your telescopes, of course, especially your binoculars, anything that you're using that's going to magnify the view of the sun, you're going to want to put a filter on that as well. Just like your eyes, your camera has very sensitive sensors, and you can damage the camera in your cell phone or just your regular DSLR camera if you do not have proper filtration on the front. So you want to make sure that you cover it up. If you have a cell phone and you just want to hold up your camera cell phone to the glasses, that's completely fine, but you can't look at the sun as you're doing it. You'll have to look at the screen and then snap your photos, again, because it's just not safe. So why do we have to make sure that we have to, what's the importance? This is the thing that you have to look out for. When you're purchasing your glasses, you have to make sure that it's designated with the ISO number 123122. It must have the manufacturer's name and address printed on the product. And most importantly, they cannot have any scratches or any tears. If they have any scratches or tears, you have to throw them out and you have to get a new pair. And even the tiniest little pinprick can let in enough light that can damage your eyes. So you want to make sure that when you buy your glasses, or if you're given glasses, that they have the right certification. And this is true of the viewer cards that sometimes people use. You have your Eclipse glasses, of course, and then you have filters for your cameras or binoculars. But if you have a solar telescope, something that's dedicated, you should be completely in the clear. Now, what happens if you decide that you're not going to use a filter and you're going to look at the sun and you're just going to completely disregard what I'm talking about? This is what you don't want to do when you are looking through the telescope at an eclipse. So you want to make sure that you have a filter on the front. You never want to look with just the solar glasses, because the sun will burn a hole through the glasses and ultimately damage your eye. And it only takes about 20 seconds for this to happen. And you can see how intense that sunlight was, and it just full on cooked the glasses. So imagine what it can do to your eye if you don't have the proper protection, the filter on the front of the telescope. It is not safe to just look through a telescope with solar glasses on and no filter on the front. And just to drive the point home a little bit further, I accidentally, back in 2017 for that eclipse, as I was putting my stuff away, I accidentally took off the filter. I put the filter away, and I had left the dust cap on so that I can, pack down the rest of my equipment. And it only took about 25 seconds for the sun to completely melt a hole through the plastic cap that covers the eyepiece on my telescope. So again, just imagine what this can do to your eyes. I don't even want to imagine. So, viewers and safety. Step one, go outside. If the weather is good, if you have even in partially cloudy skies, you'll still be able to see the eclipse. If it's not raining, that's great. Put on your eclipse glasses, and then you look up and you say, "Ooh, ah," and that's how you enjoy the eclipse. This is how you'll actually put on the glasses. You will look down first, you'll pop them on, you'll look up, and then when you're done, you're going to look down and then take the glasses off again. You never want to take them off as you're looking up at the sun. And I know it seems like it's common sense, but you would be surprised how many people actually take them off as they're looking at the sun to go look at it with their eyes, and then they'll put them back on and they'll take them off, but they won't actually look down to take off the glasses and protect their eyes. Another thing that you can do if you are just a little too nervous about it and you just really don't want to risk your eyesight, you can do indirect viewing where the sun is behind you. And you can use a colander from the kitchen, you can use a slatted spoon, or you can cross your hands with your palms kind of up toward the sun, and you'll be able to cast these really cool crescent shapes on the ground. If the weather warms up enough and we actually have leaves on the trees by then, you'll also see the leaves casting these really cool crescent shadows on the ground, and that's going to be for the entire duration of the eclipse from probably maybe about 20 to 30 minutes after it starts. That's when you'll really start to see those crescent shapes, because that's the moon covering the sun, so that's that projected image that you're seeing. Also, what you can do, if you've got an empty box at home, you can of course make a pinhole projector. All you would need is some aluminum foil, some tape, and either a pair of scissors or a utility knife and an empty box. And you can make yourself a pinhole projector by cutting out two little squares at the top, taping the aluminum foil to one of the squares, and then pushing like a little pin prick in the middle of the foil. And then at the bottom of the box, that white piece of paper that you've taped down there, you'll be able to cast the sun's image on the box, and then you would just look in through the other hole that you made, the second hole. So you'll be able to watch the eclipse for the duration completely safe, because the sun will be behind you. It's indirect viewing, and you won't have to worry about your eyesight. So why am I encouraging you to go to totality? Why am I encouraging you at all to experience this eclipse? The reason why is because we won't get another chance for a little while. It won't be until 2045 where the entire region will experience at least 50%. Now, for those of us keeping score at home, 2017, the New York City region, or the tri-state region, I should say, got 72% totality. Next month, we'll have 90. So the one in 2045, 21 years from now, it still won't be as good as what we experienced in 2017. So, not great, but not terrible. 50% is still a nice eclipse. Again, if you want to travel into totality, do it. But 50% is still not bad. However, if you decide to wait and you say, no, I don't want 50%. 50% is not as good as 72, and it's not as good as 90. I want even better. We will have a total solar eclipse in the tri-state region on May 1st, 2079. So, it's going to take some time, but we will get there. For my part, I can only hope that I'm in an old folks home by then. But we'll see. In conclusion, make sure that you enjoy the eclipse, no matter what you decide to do. If you decide to stay, if you decide to go, make a party of it. I know it's a Monday, but it's going to be so long until we have another one of these eclipses that you just want to enjoy it with your family, with your friends. You can play fun eclipse games, like, you can do like a pin the tail on the donkey, except you have the sun and you're pinning the moon on the sun. You can eat moon pies as like a dessert. You can do all kinds of things. Make sure that your filters, no matter if you get glasses or if you get camera filters, that they have the ISO 123122 certification. Never, ever, ever looked through unfiltered equipment with only the solar viewers on or just with no protection at all. And of course, get creative, use household items. If you have a disco ball, for example, like you could go to the 99-cent store and get a little disco ball. The mirrors will cast those crescent shadows on a wall. So if you hung it near a wall, you can see the sun casting all of those crescents everywhere. And it's kind of fun and exciting. And again, you don't want to end up like this guy. So please, 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 please protect your peepers. They're the only eyes you have. And that's my time. Thank you so much. Really quickly, this is just a little bit about our organization. If you're ever in New York City, you can look us up at aaa.org. Our social media is aaa.dot.org. And we are the Amateur Astronomers Association. And we've been around since 1927, educating the public on things like eclipse safety and just about the solar system in general. Thank you.
Where's the best place to buy the glasses?
I can actually show you. So there is a list of reputable vendors online, and I will take you there right now. You're going to go to this website. It is eclipse.aas.org. And under the Eye Safety tab, you'll click on Suppliers of Safe Solar Viewers. And from there, you'll go down the list. And at that point, you're just looking for the best price. You can go ahead and purchase viewers. I will say if you're going to do it, you have to do it soon because a lot of vendors are starting to close up shop before April 8th. I believe next week is probably the last push that most vendors are going to make for Eclipse glasses because everyone is going to travel and you want to make sure that you have enough time to receive the shipment. So absolutely go to eclipse.aas.org and then you'll go into their eye safety. And then of course you can view the entire website, but you go to their suppliers of safe solar viewers and you can just scroll down the list and then pick the best vendor for you. Please, please, if you buy your glasses on Amazon, make sure that they fall within these authorized dealers lists here. Don't get your glasses on like Temu or something. Just make sure that they're from a safe vendor.
If the heat gets hotter, if the sunlight gets brighter when a solar eclipse occurs, how come it gets colder? Shouldn't it get hotter instead?
So it's not that it's getting hotter. So what happens is as the moon is passing in front of the sun, you'll get a more concentrated light with the sun going through just going hitting the ground or going through your equipment. But then also I like to think of it as sort of like when you're using a hose or if you're running water through a faucet and then you cover half of the faucet with your thumb and then the sprayer gets a little bit stronger, right? All of that light and that radiation, that solar radiation that hits the ground naturally and scatters across the atmosphere just becomes a little bit more concentrated. When the moon is finally eclipsing the sun, I would say probably to about maybe 70% is when you start to feel that temperature change. You'll start to feel the temperature drop. It'll maybe get about 5 degrees cooler, not significant, but it'll get 5 degrees cooler where it'll be a little bit noticeable for a few minutes until you start to see more of the sun as the moon is just moving across the orbit. So it's just more concentrated light and more concentrated radiation. That's the harmful part. It's not the temperature.
Will the eclipse experience change if it's raining that day?
That's a good question. So if it's raining that day, you can still expect the temperature to drop. You can still expect it to get dark. You just won't see any of it. All of the things that will naturally happen with the eclipse will still happen, but because of any cloud cover or any rain, you just won't see it, but you'll definitely feel it. You'll definitely feel that little bit of the temperature kind of drop a little bit. It'll get noticeably darker. It'll be dark sort of like as if, maybe it's 30 minutes after sunset. So it'll be like, oh, it's kind of like dusk out. And then it'll start to brighten back up after a few minutes.
Just following up about a rainy day, is it dangerous to look up at the sun when it is raining or very cloudy out?
You don't want to do it. Yeah, just because of the UVs. That's why sometimes you'll see Under Armour makes glasses that are like polarized, and it's to help cut some of the ultraviolet light. You don't want to do it even if it's raining.
Kat, thank you so much for doing this. Your presentation was awesome. I liked your slides, especially the funny ones. But it was really great to have you here at the East Brunswick Astronomy Club. We hope to do it again. And yeah, another round of applause for Kat.
Thank you so much. I hope you guys have clear skies. I'm wishing you all the best. For now, just get outside. Go do some stargazing.